Daniel Gomez Blanco, welcome to the show. It's great to be doing this follow-up interview with you. You had a great talk at OliFest about rolling out 300 services migrating over to OpenTelemetry from OpenTracing. So just for people who didn't see that talk, could you give just like a quick recap of like what your situation at Skyscanner was and how you performed that rollover?
Yeah, so basically what we tried to achieve over the past couple of months was migrating from OpenTracing to OpenTelemetry. So we had all our tracing libraries using OpenTracing and sending spans to Lightstep, and how we basically created this migration path that was completely frictionless. One of the things that we wanted to avoid was to have like broken traces and things like that. So basically, is by using a combination of helper libraries to configure things, and also OpenTelemetry shims for OpenTracing, we basically did that migration in a way that was backward compatible. And then basically for people that were service owners, it was just purely a minor version bump on one of our helper libraries. So I'm quite happy with it. I think it was pretty much transparent the way that it happened. And yeah, we now are fully migrated to OpenTelemetry.
Awesome. Yeah, that makes me extremely happy. We put a lot of effort into ensuring that OpenTelemetry would allow people to seamlessly migrate over from OpenTracing. So I'm really happy to hear the success story where you're able to do it with minor version bump. But maybe rolling back a little bit further, I'm curious about why you went with OpenTelemetry. I mean, OpenTracing, obviously it's the successor to that, but that general approach, what was the value that you saw there?
Yeah, so I think I would probably split it into issues that we had to tackle and benefits that we would get. So like side benefits that we would get. One of them was that, we had this abstraction on top of OpenTracing that allowed us to basically, for our users, for our developers, when they were using our tracing libraries, they wouldn't know if they were behind X-ray or OpenTracing as the API that was, or the SDK in that case for X-ray that was implementing tracing. So we created this abstraction layer that was giving us more problems than anything right now, because everything was on OpenTracing, and basically we couldn't really keep up with let's say updates or upgrades to libraries, and also sometimes they were prone to these abstractions that we had on top were prone to memory leaks, and the way that they managed scope was not something that was thought about when we're talking about OpenTracing scope, was not something that was thought about when they were designed. So for us, basically, I think it was around mid 2020 when we said, okay, we need to do something about this. The idea was we had two options. We could either use OpenTracing, because the OpenTracing API can also be implemented by any tracer, or we decided to basically go for the OpenTelemetry approach, and then basically provide OpenTelemetry as that abstraction layer. So we know that if we need to make any changes in the future to the SDK, we can basically tell our developers, this is your abstraction layer now, it's OpenTelemetry. It's future proof, as we know that OpenTracing will become deprecated. So that was for us saying, this is now your abstraction layer, which is OpenTelemetry. And then from the point of view, that was one of the issues that we wanted to tackle. Another one was we're trying basically at Skyscanner in general to buy into CNCF projects, and we're very heavily invested in open source. So we wanted to keep the whole instrumentation layer completely open source, and also with OpenTelemetry now as well, and we OTLP get the collection and the transport of telemetry data as well in a format that can be understood by many vendors. So these two were the main issues I wanted to tackle. And then there were the benefits of all the auto instrumentation that would replace all the bits and bobs that some of them are still useful, but some of them are now basically implemented in open source libraries and open source plugins. so we can make more use of that. And I said, as I said, in general, that alignment with CNCF as we deploy, basically, we use many projects from CNCF. It was that alignment with that.
Awesome. Yeah, definitely. It's surprising how much work goes into those telemetry clients. Just making sure, like you mentioned, scope management in all languages, that has just a surprisingly difficult design function to get correct, and memory leaks and efficiency are takes a lot of effort to do all of that, and then ensuring that the API is stable and going to remain stable into the future, so that we never ever break any API calls or instrumentation already out there. Is like, it's sometimes people are like, why is this taking a while? And it's like, actually, it's like that stuff is trickier. It's like easy to write like the first version of that, but getting the version that like paints all the way out to the edges and ensures that you're tackling all the different scenarios, including things like userland schedulers like gevent and Python and all of that. It's like tricky. And then you get to the instrumentation, and that's like maybe simple, but it's like the death of 1,000 paper cuts. There's just so much software that needs to be instrumented, and then that software is like upgrading and changing all the time, and the instrumentation needs to keep pace with it. It's a little too soon. I don't think OpenTelemetry's quite stable yet. It's like just reached stability, but my hope is that after its stability is like proven to people, a lot of that instrumentation will actually get moved natively into those open source libraries, rather than being like a module the OpenTelemetry community or somebody else is maintaining. Kind of excited to see a world where people writing software are thinking about the kind of observability data it's producing, and thinking about sort of like operational handbooks that they can build on top of that, where they're like, I give you this data, and like, here's a handbook explaining how to tune the configuration knobs based on the data you're seeing.
Yeah, I think, for us as well, we only support 3 main languages that, for all these sort of like config libraries and all these helper libraries that we've got. We're talking about Java, Python, and Node as the 3 frameworks, the languages that we support at Skyscanner. And that, it is still quite a lot of work to develop these libraries, to enable engineers and so on. And there is a lot of work that we're sort of like doing internally in these that can't really be open source, because it's very much, Skyscanner like custom, that we would like, if the moment that we start to use OpenTelemetry as well, is more like, okay, so now we can contribute these things back to the project as well.
Nice. When instrumenting your own internal libraries, OpenTelemetry has this concept of semantic conventions, where we try to sort of standardize the data that systems produce. So if it's an HTTP request, it should present itself in OTLP as this set of keys and values, so that backends can kind of have expectations about not just the format of the data, like OTLP, but also the content and the meaning of the data. I'm curious, I imagine you have a lot of internal stuff at Skyscanner that needed to be instrumented. Did you do anything like that as far as like coming up with standards for how you report from those systems?
Yes. So I think another one of the discussions that we were having in 2020 with, I think at the time, there was one team that was in charge of these, of the enablement of tracing. And there was another team that was in charge of login, and another one of metrics. Now we're sort of like more, I think we took that sort of like OpenTelemetry approach of like, correlation between different pillars, and we put that in the inter-organizational structure as well. So we have, one team that basically is responsible for the enablement of those things. But before we started that, we had conversations around semantics, right? Semantic conventions at Skyscanner. And what do we call a service, or a service name? What key should we use for the AWS region? Things like that. Because between our logs and our traces and our metrics, well, it was a bit of like, bit disjointed.
Yeah.
So I think one of the advantages now with OpenTelemetry, and that was another one of the sort of like extra benefits, is that those talks that we had about standardizing on something, they sort of like, they have become, we don't need to decide ourselves. It's like, it's part of the OpenTelemetry semantic conventions, and then we sort of like, we will follow those, and that is across all the pillars. And I think from our point of view, that centralization or that enablement, those config libraries that we've got that set up the SDK and that configure the resource and the exporter and so on, they sort of like make sense. They make sure that some of the common attributes that we've got, that sometimes are picked up from environment variables, sometimes are picked up from config, sometimes are sort of like derived from other stuff, is so all of them are in one place and all of them are common across all our services. So so having those, that is super valuable for us to be able to correlate things then in tracing, and in the future with metrics and logs as well. But yeah, for us, that helper library was quite useful.
That's actually a good pivot point for organizations who are thinking about deploying observability for the first time or doing a greenfield deployment of OpenTelemetry. I think especially tracing, people are maybe used to logs and metrics where maybe there's less setup work you can do because it's very point by point. You just like tack on a metric here, tack on a metric there. But as soon as you switch to adding the kind of context that you get out of tracing, now you have to be flowing all this stuff through. And there's a huge amount of value that comes out of that because you get all of these correlations, and things like trace IDs become really valuable. But the effort involved in standing it up can go up. And so I'm curious, based on the work you've done, if someone was starting a greenfield observability effort or switching to OpenTelemetry, what would be your suggestions, like the most important things to do or think about as part of that effort?
Yeah, I think if you were to start greenfields and like, basically start with OpenTelemetry, there is a lot of stuff that can be used already. That is like, for example, resource discovery. Some of the OpenTelemetry distros already do a bunch of that for you to annotate the resource that is producing tracing. I would say that is making it easy for developers to enable tracing and enable that sort of like context propagation across the whole stack. I think that for us was critical, and that is why we made it easy to migrate as well, because yeah, you're the service owner of something in the middle of a transaction, of a trace, and you might not be interested in tracing, but if you don't propagate context correctly, if it's not annotated properly and so on, you're just basically going to not just affect your service, but your upstream and downstream dependencies will also be affected. So so I think for us is making I think that the advice that I can give is to make sure that there is like standardization on at least on the basics of like service name or like placement or like cluster placement, things like that, so you can basically identify where the regressions are happening when they're happening.
Yeah. And even though OpenTelemetry provides things like SDKs and provides all these useful pieces, I imagine it's still desirable to take some of that stuff and centralize it as much as possible, like the initialization stuff and all of that. Is that a thing you do at Skyscanner?
Yeah, so to go into a bit more detail, yeah, these libraries are, well, if we're talking about Drop Wizard, for example, that we use as Skyscanner, is a Drop Wizard bundle, right? So when you, well, at Skyscanner, we've got these things that we call M-shell cookie cutters, which is M-shell is something that's called comes from microservice shell. So there's a bunch of libraries that do things like setting up your gRPC clients or your secrets and security and so on. One of the things they do at startup is basically, pick up, as I said, environment variables, config, and then configure in our case, is quite a simple setup in the way that we've got it now, is configures an OpenTelemetry instance. configures the open tracing shim as well. But from the point of view of OpenTelemetry, configures that with a resource that is basically annotated with a set of common properties. And then that it does that at startup. So the only thing in our case, the only thing for the service owner to enable is a flag that says OpenTelemetry enabled true. And then basically that bundle will pick it up. In Python and Node is something similar. It's just basically, just call something to initialize tracing, and it will initialize all tracing for you with the appropriate attributes and exporters. So yeah, so then what we do is, as I said, quite simple resource, batch exporter or batch processor with an OTOP exporter. And from the service instrumentation, that's what we've got at the moment.
Yeah. And I think there's, at the heart of this is kind of a delegation of work issue, which is application. You want to avoid a situation where the operators, who are generally the people who need to make configuration changes, they notice a certain kind of resource. By the way, for people who don't know what resource means, this means describing the service itself. So like what Kubernetes cluster it's running in, what machine it's running on, what's the name of the service, those kinds of things. What region is it in? They may want to add or manipulate that data. They may need to tune things about, say, sampling or buffering and all of that. And having to make those changes by going around to every service team and saying like, oh, by the way, could you fiddle with this? Just creates friction and churn, even if you have a DevOps environment where the teams are still involved in the operations. There's a certain amount of needing to kind of decide these things globally and roll them out. And so just packaging all of that up in a library so that once those decisions are made, it can go as an update into that library, and all the application developers or service owners need to do is just upgrade and redeploy. But
we had a case recently as well where we said, well, now we need so there's one property, one tag of a span that is service.instance.id, for example, that we didn't have, which is supposed to identify the specific replica in a deployment of that specific instance of a service. And yeah, we didn't have that. We sort of wanted to add that. And then, yeah, as you said, for us, it was just a simple change to a library. For the developers, it was because we use Dependabot as well to bump. So they get an automated PR as well. The only thing they need to do is merge that patch version or that minor version. Yeah.
Right. Yeah. And configuration management becomes key. I think this dovetails. So we've talked about client setup, like all of the stuff that you would implant into your services. But OpenTelemetry has another component called the collector, which is a separate service that you run that can also do configuration management in addition to data processing and a lot of other useful things. So that's sort of the part of the telemetry pipeline between your services and whatever backend is receiving and analyzing the data. And that can also be a useful tool for configuration management and other things. So I'm curious at Skyscanner, how are you making use of the collector?
Yeah, so we find that as well really, really powerful. I mean, the fact that at the moment we're deploying collectors as deployments in every cluster, in every one of our Kubernetes clusters. And from the point of view of a service, they've got just one host name, which is something like OpenTelemetry.skyscanner.something. And then, so basically they publish their spans there. From that point on, it is completely, and we can make changes to configuration very quickly in the way, for example, that we want to push spans to Lightstep, or we want to push spans to somewhere else, or we want to export metrics from the spans that are going through. We want to aggregate these metrics, get metrics from the spans that are going through. All that we can do at the collectors without affecting the services that are running. So that makes it even faster to apply any change. And when you start at the moment, basically, we've only got the collectors are quite simple because they basically go through, there's a pipeline. You've got a receiver that is, in our case, is OTOP, as in a gRPC receiver, and then it goes through the pipeline, which at the moment it doesn't really do much. It just basically passes through and goes to exporters, right? In the future, we will do that. We know that there can be things that we can do in the middle. For example, if you want to transform an attribute, if you want to sort of if you want to drop attributes, for example, or to drop spans, or to start to do tail sampling at the collector level instead of at the sort of like Lightstep SaaS level, those are things that we're looking into. So we started with a simple approach, which is basically use the collectors as pass through, and they actually are super cheap to run because they're not doing much. Well, they're not doing much, but they're still processing around 400,000 spans a second. but they are sort of like, they are just passing through. But in the future, in the near future, we plan to add more and more functionality to the collectors themselves, and that allows us as operators to start to manipulate the data, or to generate other metrics, or to export to multiple places.
Right. So if I understand correctly, when you deploy the clients, those clients have a standard configuration set up as far as where they're sending the data. So they just have a stock domain name that they're sending the data to, and they're sending that data in the OpenTelemetry's default OTLP over gRPC format. Mm-hmm. And then you're using DNS to actually manage where they're actually sending the data, so like which collector they're getting it and all of that?
Yeah, we have an Istio service mesh in our cluster. So basically they get routed to the request. We do get a bit of some benefits from running an Istio, like circuit break-in, retries and things like that. But from the routing perspective, yeah, they get routed to the closest healthy deployment, which normally is in the same cluster on the same AZ. But we make sure that gives us the high availability as well from the collector's point of view. Right. And from the configuration side is simple, because it is just basically one endpoint, one gRPC endpoint that you connect to. It is configurable as well. So these libraries, you can say, well, I want to point it to another OTLP endpoint because you want to test something. But the default is to just one endpoint that works across clusters, and even outside the cluster, we have it basically going through an NLB into an AWS load balancer into the clusters themselves. So it works quite well.
Yeah, I think that's a really key thing to call out, is just we tend to bake and hardwire a lot of operational or system level configuration into our services kind of by default, but with the advent of service mesh, or just using DNS and gateways intelligently, it's possible to standardize the configuration within the applications, which means if you need to make some kind of operational change about where the data is going or what you're doing with it, you're not having to redeploy those services and especially not having to do some kind of coordinated redeploy across a fleet of different services. Instead, the operator can make choices either by redeploying these telemetry specific components or their service mesh components, or just like updating configurations in various places, like inside of the load balancer. And that allows for I imagine that allows you to be a lot more responsive to changing needs when it comes to telemetry, which is important because there's actually this is like a lot of data, right? It ends up being like a fairly large system in and of itself in terms of resource usage. And when you're thinking about it, it's actually, it can get, when your system's large, the piping all of the telemetry data out of it becomes actually a problem you have to think about.
Yeah, it will allow us as well. So as I said, at the moment, we're only running one deployment of collectors per cluster. But when we start to get logs and metrics, we can think of other other deployment strategies for collectors that, for example, that involve running 2 layers of collectors, or, well, I mean, I guess from the point of view of the client, yeah, it'll still be just one endpoint, right? What's behind that is up to the operators to decide what collector architecture you want to go for.
Right. And you can also start doing things like data scrubbing, and I've seen people even do data versioning. So if you change your standards, like we wanted to report data in this one format, now we want it in another format, or a new format comes out and you still have some dashboards that are expecting the old format, you can use those collector processors to manage the data to solve a lot of those problems. So as your system matures, you kind of end up with that kind of legacy stuff, and it's a good place to deal with it. Okay, so I feel like we're at time at this point. So I want to, this has been super helpful. It's been great talking to you, Dan. And I would like to turn it over to Q&A real quick. So if people want to use the Q&A tool, you can type in your question. Otherwise, there's a raise hand tool. If you raise your hand, then I can unmute you. And I see Sankyo would like, I saw a raised hand. Well, if you'd like to talk, you can raise your hand again. He wrote his question. Developers want to see the span for all errors. If you use trace ratio, the error span may drop. How do you deal with these cases? So this is the issue with sampling versus not wanting to miss rare but important errors.
Yeah, so I guess, we're talking about the sampling at the collectors, for example. If you do tail sampling at the collector level, you can do you can apply policies there and say, well, you want to keep all traces that contain one error, for example. So you can do that sort of thing, and keep the traces that contain errors, and then drop then apply your trace, your ratio, and the rest of traces. So there are policies that you can do at the moment in OpenTelemetry collectors. If you use a vendor, for example, like Lightstep, that gives you the tail-based sampling from Lightstep, you will get that distribution of errors and that tail-based sampling from the Lightstep product itself. So and I think it is, as long as you're showing, I think what tracing is showing what changed and what is happening to your system, what is the regression. I think that's what developers care about. And that, but yeah, as I said, maybe, I guess, one of the benefits of using tail sampling in the collectors is that gives you perhaps a bit more control about the tracing. But it does have all the drawbacks. So yeah.
Yeah. And I don't do a lot of Lightstep plugging because it's not my thing, but I do want to mention here, this is actually a thing I really like about Lightstep's architecture is by having tiered sampling. So you have at stage 1, you're retaining all of the data for a certain time span with the new microsatellites. That time span is like 3 days. So if you're live debugging something, you're looking at unsampled data. And then what actually ends up getting stored is based entirely on what data you're recording. And I think this is a really great way to do this. I hope to see other systems do it in the future. So Lightstep knows, what kind of dashboards you've set up. It knows what data you're already interested in. And so the only data that gets permanently recorded is data that would feed into those dashboards. And the rest of the data after 3 days or whatever your time window is just gets deleted. So you don't have a storage cost associated with it. So that kind of stuff is tricky. The collectors are not coordinated enough yet to do something quite that advanced, but kind of imagine in the future, once we get past a lot of the baseline table stakes stuff of getting OpenTelemetry stable and out the door, some of these more advanced sampling things might be things we can address at the collector level.
Yeah, I actually see another question there that is related to this, and maybe should I?
You want to read the question out so people?
Yeah. So if I try to use the tail sampling processor, it supports only single instance, so multiple collector pods cannot be launched. How did Skyscanner solve the problem? Yeah, as I said, we are not doing sampling at the collectors yet. We are thinking about it and we're considering options. There is ongoing work to allow this to be implemented. And the way it works is by basically routing all spans in a trace to a specific collector. So the way that it works is that there is a load balancer processor or a load balancer exporter that basically will send spans for a given trace hash or trace ID hash to a specific collector, right? And then you can benefit from having that deployment of collectors and as well from being able to do tail sampling. It does rely on things being in the same cluster, but there is ongoing work to be able to tackle that.
Awesome. Yeah, I'm looking forward to where all that goes. It is very tricky though, having been part of implementing it over here.
I think for us, with the Istio mesh as well, with the service mesh, where we have a multi-cluster service mesh, it becomes even more complicated because you need to basically deal with the fact that your spans may be in different clusters. But yeah.
Oh yeah, and don't get me started about like the fractured way we're building a distributed operating system here. That's a whole other rant. But we do have another question here from Andrew this time. Daniel, for the services that you migrated, were all within containers. It does seem support for Lambdas are a bit behind with OTel.
Yes, so all the services that we migrated are either on ECS or Kubernetes running on AWS, but we're not supporting tracing for Lambda as a Skyscanner. There is an ask for it. Basically, people are asking for it, so we will have to support it at some point. Just not at the moment. But I think as well there is maybe you know more about that than me, Ted. About the support for Lambdas.
Yeah, I've been working on that with AWS. So there is some Lambda support. If you go into OpenTelemetry on GitHub and type in Lambda into the search, you'll find the OpenTelemetry Lambda repo, and there's support there for several different languages. You can also home roll it. It's just Lambda has some particular needs that make it the setup you need to do there is like a little more specific. For example, the way you get your tracing data, like your tracing headers, don't show up. You don't have direct access to the headers. The headers exist as environment variables. So how you would actually unpackage those and start a trace is just kind of Lambda specific. So there's the code that's in that repo is wrappers that use Lambda service layers to kind of move all of that tracing setup and teardown code sort of out of your Lambda. So your Lambda gets wrapped with code that does all of that configuration. But you don't technically need all that to do tracing on Lambda. It's just you would have to do a lot of work by hand to go grab that X-ray header and make your trace and all of that. But it's something AWS is very committed to. So you should see a lot of good Lambda support getting smoothed out over the next 6 months. Cool. And that's all the questions I see. We're over time, so we'll probably have to end it here. But thank you everyone for showing up. I hope this was useful to you, and please, you can hit me up on Twitter. I'm at Tetsuo on Twitter. Daniel, if people want to follow up with you, what's the best way for them to get a hold of you?
Yeah, I'm as well on Twitter, like Dan Gomez Blanco. You can just hit me up there.
Yeah, and I should mention also OpenTelemetry. We live on Slack. We're on the CNCF Slack instance. So if you just go there and go to the OpenTelemetry channel and say hi, we're all hanging out there. All right. Well, thank you everyone who came. Daniel, thank you so much for doing this interview, and
Thanks for having me.
look forward to the future.
Right. Cheers.